All right, so this is an instructional demo on how to set up dynamic VLANs using Ruckus wired and wireless infrastructure and an RxG gateway. So we've got a zone director 1200 for our controller. We've got a couple APs connected. We've got an existing network, but what we want to do is add a second WLAN, which will dynamically assign clients to a VLAN from a pool of VLANs. So I've already configured the switch fabric, but that's usually the first thing you want to do is make sure that your VLANs are chunked throughout your switch fabric from your gateway to your access points. So in this case, I've got two switches that we can take a look at. We've got SW1, and so if we show the running configuration, we can see that we have some VLANs that I'm using for some particular purposes, but I've got VLANs 11, 12, and 13 that I know to be free and available for this purpose. And you can see that I have those tagged on most of the ports. In fact, this is all of the ports. Yeah. And so that will allow traffic to get from my access point all the way to my gateway on these VLANs. And we can check my secondary switch and make sure we have the same configuration here. And we do, 11, 12, and 13. This one I believe is being used right now. So we're going to configure our RxG to put VLANs 11, 12, and 13 into a pool and dynamically hand them out to new clients that connect to this new WLAN that we're creating. So the first step, after making sure the switch fabric is all good to go, is we should probably configure our networking, because right now those VLANs don't have anything actually passing traffic, much less a gateway or a DHCP server. So we'll do that first. So we'll call this DVLAN lab, and this is on IGB3. This is going to start with VLAN 11. We are going to auto increment these, yes, per subnet. So each VLAN will get its own subnet in a ratio of 1 to 1. We don't have the address built yet, so I might not be able to create this. Oh, I can. Okay, good. And then I can create my DVLAN lab network address. This will not go to the Ethernet interface, but rather to the VLAN. And we will use 10.255.99.1. And we'll give each one a /24. We will auto increment this 3 times, which means we'll build 3 networks, and each one of those will get mapped on to a subsequent VLAN. And we'll create a DHCP pool for that range as well. So let's go ahead and do that. We can refresh the page and see that now our DVLAN lab VLAN interface has been spanned out from the auto increment configuration to cover 11, 12, and 13. And we have a network on each one of those, .99, .100, and .101, and it doesn't conflict with any of the other networks that are on this particular system. All right, so now that we have the networking, we can go ahead and do the radius configuration. Radius is the mechanism by which the RxG and the zone director are going to communicate. So first we'll create our radius server. And again, we'll call this DVLAN lab, just so it's obvious to me what we're using. We're going to make sure this is set to active. We're going to use the default ports. And I don't know that there's anything else that needs to be configured, except I probably need to make sure the zone director policy is selected so that the zone director has access to this radius server. Yeah, I think that's all set. Then we need to create a radius server realm. In this case, we're going to create a very simple configuration. So we are going to do per device VLAN sharing. We're going to select our DVLAN lab VLANs. That's the pool that will be available. We are going to allow reusing VLAN tag assignments. And the zone director is the infrastructure device that is going to be issuing requests for VLAN assignment. And then for the attributes, these are the default attributes that are selected, and these simply get passed along with the radius response to inform the infrastructure, in this case the zone director, what VLAN tag assignment that particular device received. And it's up to the wireless infrastructure to tag that traffic. So we're going to create this. I think everything there is created correctly. And then we can go over to our zone director. I'm going to copy this shared secret here because we'll need that when we configure the radius server on our zone director. And that's probably the first thing I can do is, I think it's under services, AAA servers, is we need to create the radius server in the zone director so the zone director knows where to send radius requests to. So we'll call this the RxG. It's a radius server. I don't think we need, TLS is not enabled. This is all happening over the management network. I think PAP is the normal authentication method. The IP address would be 10.255.0.1. Port is 1812. Here's that shared secret that I need to paste in here. And I think the default retry policy is sufficient. So we'll create that, and an easy way to test this is to, they have this test mechanism built into the zone director, and what we can do is just put in some credentials, and what we're looking for is a bad outcome for this test would be for the request to time out. A good outcome would be that the credentials are not valid, because when the zone director sends this radius request, it's not going to include credentials. So let's test this out and make sure that we get, and this is good. Even though it's failed invalid username or password, that's normal. But this does mean that the zone director was able to communicate to the RxG. All right, so now that we have our radius server registered with our zone director, we can go to the wireless LANs. Can ignore all that. And I'm just going to create a new SSID, a new WLAN, and we are going to configure it to use dynamic VLANs. So we'll call this one DVLAN test. And it is going to be a standard usage WLAN. We're not using hotspot or anything like that. And we are going to do 802.1x MAC address authentication. So this is EAP plus MAC address authentication, and we need to select only MAC address authentication. We're going to be sending that to the RxG. That's the only authentication server we have. And let's go to advanced options. Here's where we should select what the default VLAN would be, and there should be a checkbox here for dynamic VLANs. Yeah, so this is the default VLAN. In some older versions of the zone director, I used to set this to 99, but I think as long as you have enabled dynamic VLAN checked, then Ruckus will never dump someone into this VLAN by default. In my case, 1 is the management VLAN, so that would be not ideal, but I don't think that they have that behavior anymore. I think if enabled dynamic VLAN is checked, they have to get assigned to VLAN or they don't get on the network. All right, I think that's all we need. So I'm going to go ahead and hit OK. So we've created this new WLAN, and I'm going to connect to it. And what I'm looking for is I should get a VLAN tag assignment in the RxG when my client device connects, and I should be able to see that in the zone director as well. So let's go over here to wireless clients. As you can see, there's nothing connected to that new WLAN. I'm going to go ahead and give that a shot. DVLAN test, here we go. All right, does not look like it's functioning. I don't think I'm going to be getting any VLAN tag assignments. That might be due to a misconfiguration in my radius server. All right, I think what's happening is that the zone director is caching the invalid response. So I'm just going to go ahead and delete this SSID and recreate it in the hopes that I can expire any potential cache that might be causing it to not send the radius request to the RxG anymore. Okay, there we go. Now we got an OK and we are connected. And if we go to clients, we can see now we have this client, which is my phone, connected on VLAN 11, and we can even check the radius request to make sure that it's getting on the VLAN that it was instructed to. We can see in the RxG that it did respond with this tunnel private group ID as VLAN 11, and so the zone director correctly put the device onto VLAN 11. And then here in the RxG, we can see that in the interface assignments, you'll have a VLAN tag assignment, which is this device onto tag 11.